Question number 1. The diagram shows the result of dropping a purple crystal into the water. So we can see after 5 hours, this crystal, first it is dissolving, and then it is diffusing from a high concentrations to the low concentration, and it's making homogeneous solution here. So dissolving is not chemical reaction, it is a physical process. So which process taking place in this experiment? So chemical reaction, that is cross, diffusion is taking place, and dissolving is taking place here. So correct answer is D. Question number 2. Which row about the element, mixture, compound is correct? So element is the group of the atom which have same property, mean they have the same proton number. And the mixture is the group of the atom or a group of the compound which have no chemical interactions, mean they don't have any chemical bond. While the compound, when two atoms react together and they are making a chemical bond and produce a new substance, that is compound. So here we have a metallic element in the first column. So you can see that the copper is our metallic element. What about brass is the mixture of two different metals, zinc and copper. So that's why the A and C is our correct option here. So we're going to move to the column number 2, the non-metallic element. So sulfur is a non-metallic element. So here we can find our answer in second column if the A is wrong. So C is correct, our answer. So you can find your answer, and this answer you can confirm in the third and fourth column. So in a third column, the mixture, so we have the brass is a mixture of two different metallic atoms. For example, zinc and copper, they mix together. So that's making alloy. So what about copper is metallic element? Here, the compound is, the methane is a compound, while the sulfur is non-metallic element. So C is our correct answer here. Question number 3. The atomic structure of 4 particles W, X, Y, and Z are shown. So which particle are isotope of same element? So here we define isotope. The isotope have same proton number, but the different neutron number. So here in the W and Y, they have the same proton number, 2 and 2, and their neutron number is different. That is a 2 and 3. So that is the correct answer. While you can see X and Z, they have the same proton number, but their neutron number is also same. So that's why this is not correct according to the given definition. So the B is our answer correct. That is W and Y are isotopes of each other. We can also define the isotope like the element. So the atom belongs to the same element which have same chemical property, but they have a different physical property. Or they have the same atomic number, but they have a different atomic masses. So examiner can also ask the question related to any definition of isotope. The question number 4. Which statement explain why the isotope of same element have same chemical property? Now, this question is related to the chemical property. So isotope of a same element, they have a same proton number. If they have a same proton number, so number of electrons are same. So all isotope, if they have a same number of electron, so their outermost shell electrons are same. So that's why they're having same chemical property. So the option A is correct according to this, the property. So they have a same number of the electron in their outer shell. So A is our correct statement. The B, they have the same number of the neutron. So it is wrong. Why? Because the number of neutrons are different and they have a different number of a proton. The C is wrong. Why? Because they have same number of the proton. While the D, they have the different mass number. So it's correct that they have a different mass number, but the mass number is describing physical property, not chemical property. So A is our correct option here. Question number 5. The nitrogen forms a nitride ion with the formula of N-3. So we can see that the nitrogen is present in the 5th group in a periodic table, and its proton number is 7. So it means the total number of electrons are 7. So its electronic configuration will become 2 and 5. And what about this nitride ion? They will take 3 electrons. And in this way, the total electron will become 7 plus 3, 10. So electronic configuration will be in a first shell, there is 2. And in the second shell, they will become 8. Now here question, which particles does not have same electronic configuration as the nitride ions? So we can see that the aluminium, this is present in the group 3. So this contain a proton number are 13. So now this proton number 13, if it is having plus 3 oxidation state, so it lost 3 electron. So that is equal to the 10. So electronic configuration will be 2 and 8. In the same way, the chlorine, this is present in the group 7. So the proton number are 17. So here total electron are 17. So when it will take 1 electron, so that will get minus 1 oxidation state. So in this way, that total electron will become 18. So electronic configuration is 2, 8, 8. So this is not similar to the nitride ions. So that's why the B is our correct answer here. If you see that the answer C, so sodium, that contain proton number 11. So plus 1 oxidation state, it will lose 1 electron. So that is equal to 10. So electronic configuration is similar to the nitride ion. In the same way, the oxygen that contain proton number 8, when it will gain 2 electron, so that will become total 10. So electronic configuration become similar to nitride ion. So here, the correct option is B. The question number 6. Which row describes the formation of single covalent bond in methane? So you can see in the right side, the covalent bond contain 4, there is a carbon contain 4 covalent bond. So you can see that each hydrogen is sharing 1 pair of electron between carbon. So when we can see that dot and cross the model of the methane, so you can see that in methane, each hydrogen is sharing 1 pair of electron with the carbon. Now, outermost shell of the carbon, there are 8 electrons, and it's completing octet rule, while the outermost shell of each hydrogen contain 2 electrons, and it's a completing duplet rule. So both are having to complete their oxidation state and outermost shell, and they have a nearest noble gas electronic configuration. So we're going to check this option A. The atom share the pair of electron. It is correct. The both atom gain the noble gas electronic configuration. Yes, it is correct. So A option is correct here. So B, the atom share the pair of electron. It is correct. The both atoms have the same number of electron in their outermost shell. So it is wrong. Why? Because hydrogen contain 2, while the carbon contain 8. So that's why it is wrong option. The C, the electron are transferred from one atom to another. When we say transfer, that is ionic bond. What about here? There's a covalent bond. So that's why the electrons are being shared between 2 atoms. So that's why this transferred word is wrong here. So that's why our correct option is A. The question number 7. Which formula is empirical formula? How we define empirical formula? The simple whole number ratio between the atom of a same molecule. So different atoms which are present in a one molecule, if there's a simple whole number ratio of that atom in a molecule, that is empirical formula. While if we define actual number of atom in a molecule, it is molecular formula. So we can see that which formula having simple whole number ratio. For example, if there is a C2H4 and O1, so that's the simplest whole number ratio. We cannot make it further simplified. What about in a B option? You can see carbon contain 4 atoms, hydrogen 8, and oxygen 2. So we can further simplify by the 2 table, and this will become 2, 4, 1. So that's why it is molecular formula. Now the C option, the carbon are 4, hydrogen is 8, and carbon number is 2. So we can further simplify it into 2, 4, 1. So that's why it's also molecular formula. And the D option, the carbon 4 and hydrogen 8 and oxygen 2. So we can further simplify by the table 2 into 2, 4, 1. So that's why it is also molecular formula. Our correct option is A here. The question number 8. Heating iron sulfide in air produce sulfur dioxide. So iron sulfide react with oxygen and it is producing iron oxide, plus it's producing sulfur dioxide. So what is the maximum mass of sulfur dioxide produced from 120 kilogram of the iron sulfide? Here in this question, with the reference of reactant, we are going to find the concentration of the product. And first, we will check that the balanced chemical equation. So for example, iron sulfide have a 4 mole and sulfur dioxide has 8 mole. So it means that the ratio of iron sulfide to the sulfur dioxide is 1:2. So for finding the mass of a sulfur dioxide, the first we need to convert the iron sulfide mass into mole. And then with this reference, we will find the mole of sulfur dioxide, and then we will convert these mole into the mass. For example, for finding the mole of iron sulfide, we need molar mass of the iron sulfide. So molar mass of iron sulfide, the iron with the relative atomic mass, that is 56, plus the sulfur is 32 multiplied 2. So we will get the number 120 gram. That is the molar mass of iron sulfide. Here, the moles of iron, so 120 multiplied 1,000, we will convert it into gram. Divided by 120 is equal to 1,000. So overall, the mole of the iron sulfide is 1,000. We can find the mass of a sulfur dioxide. So what the reference of iron sulfide with a sulfur dioxide is what? 4:8. So for example, if you're having the 4 mole of iron sulfide, so we are producing 8 mole of sulfur dioxide. But if you have a 1,000 mole of iron sulfide, so what quantity of sulfur dioxide we are producing? That's a cross multiplication method. So we're going to have this cross multiplication. Mole of sulfur dioxide is equal to 8 multiply 1,000 divided by 4 is equal to, that's a number 2,000. You can also find by a simple way, for example, the ratio of iron sulfide to the sulfur dioxide is 1:2. So for example, if the iron sulfide have 1,000 mole, so sulfur dioxide have 2,000 mole. So you can directly find, but if the same question is coming in a paper 4, so you have to calculate. So mass of the sulfur dioxide. So if you got a mole, that's a 2,000. So we want to convert this mole of sulfur dioxide into the mass. So this mass will be mass mole multiply molar mass. So molar mass of sulfur is 32. That's our sulfur relative atomic mass, plus oxygen is 16 multiplied 2, because there are 2 oxygen. So that will produce 64. Now this 64 multiplied 2,000, that will produce 128,000 gram. But we need answer in a kg. So we're going to divide by 1,000. That's equal to 128 kg. So our correct option is B here. We're going to proceed to the question number 9. Which substance produce hydrogen and bromine when electrolyzed? So during electrolysis, you should know the certain concept. For example, if you are performing the electrolysis of molten salt, so there's only salt content is there. There's nothing else is there. So in this way, the cation will reduce at cathode, while the anion will oxidize at anode. There's no problem. But if you are having dilute solution or concentrated solution, then you have to calculate something. For example, if you're having the dilute solution, so at anode, the hydroxyl ion will oxidize and they will produce the water and oxygen. And at cathode, you have to compare the hydrogen with the given metal in the reactivity series. In the same way, if you're having the concentrated solution, so at anode, the anion will oxidize, there's no problem. But at cathode, you need to be careful. At the cathode, you need to compare the metal with the hydrogen in reactivity series. So if this metal is having more reactive as compared to the hydrogen, so the hydrogen will reduce first. But if this metal is less reactive in reactivity series, mean it is coming below the reactivity series, so this metal will reduce first. So we're going to check that and this concept in this answer. For example, the option A, the concentrated copper bromide. So in this concentrated copper bromide, at anode, the bromine will oxidize and that will produce a bromine gas. What about at cathode? So we need to compare the copper with hydrogen. And you can see that the copper is less reactive than hydrogen. So that's why the copper will reduce first. And copper will reduce on cathode. And it will deposit in the form of the copper metal on cathode. So that's why the one is producing bromine and second is a copper. We're going to see that in a option B. So concentrated aqueous sodium bromide. So at anode, there is the bromine. It will oxidize. There's no problem. But at cathode, you need to compare the hydrogen with the sodium. So you can see that the sodium is a highly reactive than to the hydrogen. It's present above the series. So that's why the hydrogen will reduce first. And when the hydrogen will reduce here, so that will produce hydrogen gas here at cathode. In the same way, we have a dilute aqueous potassium hydroxide. In a dilute, the concentration of the water is more as compared to the salt. So that's why at anode, hydroxyl ion, they will oxidize and produce water and oxygen. So oxygen gas will bubble up in the form of oxygen molecule. What about at cathode? You need to compare it in the reactivity series with the potassium. And you can see that potassium is highly reactive as compared to the hydrogen. So here, hydrogen will reduce first. And in this way, we have a molten lead bromide. So here, you're not supposed to compare anything. Why? Because at anode, there is anion are going to oxidize. At cathode, the lead will reduce. So here, according to the question, we're going to compare this. Which substance produce hydrogen and bromine when it is electrolyzed? So we're going to compare this value. So here, B is our correct answer. Why? Because at anode, it is producing bromine gas. What about at cathode? It is producing hydrogen gas. We're going to proceed to the question number 10. Which statement about hydrogen fuel cell are correct? So hydrogen fuel cell is a type of fuel cell which is burning or combining the hydrogen with oxygen. So by the use of electricity, and it's producing what? The water molecule, and in this electrolysis chamber, and that's producing ion. So we define at anode, the catalyst split the hydrogen molecule into the electron. And it produce and the proton, so that will split the electron and that will produce the proton. Now these proton hydrogen ion, they will react with the oxygen and they will produce the water molecule, while these extra electron will be used to generate the electricity, and this will in turn produce mechanical energy. So here, that's overall the process for the hydrogen fuel cell. So we're going to see that which option is correct according to this given information. So the option number 1, water is formed as only waste product. So this is correct option because only water is being formed as a waste product. Both the water and carbon dioxide are formed as a waste product. So carbon dioxide is not being formed in these reactions. So that is wrong. So overall reaction is the hydrogen and oxygen react together, and that's producing water as waste product. This is correct option. And this reaction is overall exothermic reaction. This is not endothermic reaction. So that's why the option 1 and 3 are correct here. So here our answer is A is our correct answer, which contain 1 and 3. The question number 11. Ethane gas is completely burned in the excess of oxygen and produce carbon dioxide and water. So equations of exothermic reaction is given there. For example, ethane gas is burning in the presence of oxygen and producing carbon dioxide and water here. So this energy column is given there. So first, you're supposed to write the structural formula for this equation. For example, in the reactant side, we have ethene that's reacting with a 3 molecule of oxygen, and that is producing 3 molecule of carbon dioxide and 2 molecule of water. So we're going to compare first, for example, an ethene contain a 1 carbon and carbon double bond. So that is 614 plus it contain 4 carbon and hydrogen bond. So 4 multiply its value, 413, we will take from the table, and plus. So there is, we are having 3 oxygen with oxygen double bond. So we're going to multiply 3 multiply 495, and that is equal to 3,751. Now in this way, we're going to see that in a product. So in the product, we have a 2 carbon dioxide molecule. So here carbon and oxygen, the 2 double bond are there. So we're going to multiply this value 4. Why? Because 2 molecule and each molecule contain 2 double bond. So 4 multiply 799. It is a value in the given there, carbon and oxygen. Plus, so in a 1 water molecule, there is a 2 oxygen and hydrogen bond. So overall, 2 water molecule contain 4. So 4 multiply 467. That will produce the product 5064. Now, we're going to calculate this value. So energy is usually absorbed when the bonds are being broken, while the energy is releasing in the product side where the bonds are being made. So in this way, we're going to calculate this in the reactant side. That's represented as the positive. What about the energy release in the product side? This is exothermic reaction. That's represented as the negative. So the energy absorbed in the reactant, 3,751, minus energy produced in the product, 5,064. Our answer is coming in minus 1,313. This is an exothermic reaction. Why? Because the answer is in minus. So C is our correct option here. We're going to move to the question number 12. Which row describes the effect of activation energy, frequency of the particle collisions, and when the temperature of the reaction is increased? So we can find what is the relationship of a temperature to the activation energy and frequency of the particle. So activation energy is what? A minimum amount of energy which is needed to convert reactant to the product. So if we don't provide this minimum energy, so the reaction will not take place. And this is fixed for every chemical reaction. What about the frequency of the particle colliding? Their frequency is dependent on the temperature. If you're increasing the temperature, the kinetic energy is increasing. By increasing the kinetic energy, the collisions of these particles is increasing. So activation energy is not affected by increasing temperature. So there is no change in activation energy. That will stay fixed. What about frequency of the collisions? So frequency of collision, it will increase by increasing temperature. So B is our correct option here. The question number 13. Solid copper sulfate that exists in the 2 different forms, anhydrous and hydrated form. So one of this form is a blue in color, while other is a white in color. So change between these 2 forms is reversible reactions, mean blue form can convert into the white form and white form convert into the blue form. What is the blue form and how it's going to change into the white form? So we can see that this chemical reaction, for example, if you have copper sulfate, hydrated copper sulfate. So water is the part of this copper sulfate molecule. So this is called hydrated copper sulfate, and it is giving a blue color. But if you're heating, so water will evaporate. So when the water will get separate from the copper sulfate, so that will become anhydrous copper sulfate. And this anhydrous copper sulfate will produce the color white. So in this way, that's a reversible reactions. So we get to check that what is information. So blue form is basically, that is hydrated form. While if you're going to heat it, so this will change into the white by heating. So D is our correct option here. We're going to move to the question number 14. Sodium ions and oxygen ion combine together with the chromium ion, and they produce a salt, that is sodium dichromate. What is the oxidation state of a chromium in this salt? So you can see that the oxidation state are given there for sodium is +1, oxygen is -2. What is the oxidation state of chromium? So we can calculate this oxidation state, for example, on the formula we can also calculate. For example, if there is the sodium is +1, there are 2 sodium out there. What about the chromium are 2? We don't know about that. The oxygen has, and the 7 atom are there. So what about oxidation state of oxygen is 2? So we can make it equations. For example, the sodium is 2 multiply 1 plus 1. So that will produce +2 oxidation state overall. Plus the chromium are 2 atoms are there. So we can write 2x because we don't know, minus 7 multiplied 2. That's -2 oxidation state. So this will produce -14 is equal to 0. So here we produce equations. So we're going to solve this equation. So -14 and +2, that will become what? 2x minus 12 is equal to 0. So here we have a -12. So that is minus, other side that will become plus, and 2 is multiplying, other side it will divide. So that will produce x is equal to +6. So here, the oxidation state of the chromium is +6. Now here in this equation, you are thinking why I put 0 here is equal to. Why? Because there's no charge on the sodium dichromate. So that's why in equation we will put 0. But sometime in a formula, the examiner is giving some kind of charge there. For example, if there's a charge is +1, so you write +1 on the right side of the equation. If there's a -1 is given there, you're supposed to write the -1, and then you can solve this equation to find the unknown value. So we're going to proceed to the question number 15. The concentration of the hydrogen ion of 100 centimeter cube of 0.1 mole per dm cube hydrochloric acid is higher than to the concentration of the hydrogen ion in the same concentration of the ethanoic acid, in the same value of ethanoic acid. So what is the difference between which statement explain the difference of a hydrogen ion concentration in these two different acids? And actually, hydrochloric acid is a strong acid, while ethanoic acid is a weak acid. So the hydrogen ion, hydrochloric acid is completely dissociate into their ion. What about ethanoic acid is partially dissociate into their ion. So which statement is describing this statement or this reason? So that will be correct statement. For example, ethanoic acid is an organic acid. Fine, it is correct, but it's not describing this phenomena, that the strength of acid. So that's why it is that's why it's going to be a wrong statement. Second, the B, the ethanoic acid has a lower pH value than hydrochloric acid. So this lower pH value is not comparing the strength of acid. So strength or dissociation's rate of the acids. What about ethanoic acid is a partially dissociate. So that's the correct. So it's describing the correct option. The ethanoic acid is partially dissociate. What about the hydrochloric acid is completely dissociate. So we can define about the ethanoic acid. So here ethanoic acid is a strong acid, and that is wrong option. Why? Because ethanoic acid is a weak acid. Question number 16. Which oxide is classified as an amphoteric oxide? So we have 3 different types of oxide. For example, when the metal will react with oxygen and that produce metallic oxide, these are basic oxide. In the same way, when the non-metal will react with oxygen and they produce the non-metal oxide like carbon dioxide, and these are acidic oxide. But there are certain type of metal, for example, aluminium and zinc, when they would react with oxygen and they produce the zinc oxide and the aluminium oxide, they are behaving acidic and basic both. So these are called amphoteric oxide. So here, either zinc oxide and either aluminum oxide, these are amphoteric oxide. So A is our correct option here. So aluminum oxide is a amphoteric oxide. The question number 17. Which method produced the salt copper carbonate? Here, there's a knowledge-based question. The copper carbonate is an insoluble salt, and if you're preparing by combining two reactant and they produce a precipitate, and this precipitate insoluble, after filtration, you separate the copper carbonate from there. So the step number one, you need to combine the copper oxide plus sulfuric acid, and this will produce copper sulfate plus water. And then you're going to add the sodium carbonate with that. And this sodium carbonate will precipitate copper carbonate plus the sodium sulfate in aqueous form. So then after the filtration, you can separate the copper carbonate from the solution. So that's overall process. We're going to see that which statement or which option is describing this process. So first, add the copper oxide to the water. Now this directly, the copper oxide will not react directly with the water. So that's why it is wrong option. And option B, add the copper oxide to the dilute sulfuric acid. So if you're adding to the first dilute sulfuric acid and then add to the excess of the sodium carbonate, it is correct. And then we filter off to get the precipitate. So B is our correct option here. So C, add the copper to the dilute hydrochloric acid. So copper will not react to the dilute hydrochloric acid, and that's why this reaction will not take place. So that's why it is wrong option. Here, add the copper oxide to the excess of aqueous sodium carbonate. So if you're directly reacting to the aqueous sodium carbonate without making to the copper sulfate, so that will not react. So that's why according to that given equation or standard process, B is our correct option here. We're going to move to the question number 18 here. Which statement about the trend across the period of the periodic table are correct? So we can see that the trend of metallic trend of in the periodic table. So metallic character decreases if you're moving from left to right in a periodic table. So mean at the extreme left side in a periodic table, so all elements, they are highly metallic character. What about if you're moving to the right side? So these metallic characters are decreasing and until these all these metals, they convert into the non-metals. So we're going to see that in a statement number one, the aluminium is a more metallic than to the sodium. So that's a wrong statement. Why? Because aluminium is present in the group 3. And what about the sodium is present in the group 1? So sodium is more reactive as compared to aluminium. So here, number 2, beryllium is a more metallic than to the carbon. So that is a correct statement. Why? Because beryllium is present in the 3 and the carbon is in 4 group. So carbon is coming after if you move from left to right in a periodic table. So that's why it is correct statement. Now, boron is a more metallic than to the lithium. So lithium is in the first group. So that's why it is more metallic. So that's why it's the wrong option. So magnesium is a more metallic than to the silicon. So magnesium is coming in a 3rd group. Silicon is a 4th group. So that's why the 4 is our correct option. So C is our correct answer here. The question number 19. Some of information about the element in the group 2 of the periodic table are given there. So that's a group 2 in the periodic table. So we are moving from beryllium to barium. So the time taken to make the 10 centimeter cube of hydrogen gas in a 1 gram of metal is added to the cold water. So we can see that in the first, there's no reaction, then it will take 300 seconds, and further, the time is reducing constantly, 60, 30, and 10. So there's a regular trend. So the time is decreasing if you're moving from beryllium to barium down the group. So it means if you're moving down the group, so reactivity is increasing. So if the reactivity is increasing, so they are taking less time to produce the same product. So we can see that in the second column, the density. So first is 1.85, and second, it is decreasing until 1.54, and then once again, it's increasing. So that's why this trend is not clear because first it's decreasing, then it's increasing. What about the metallic melting point? This melting point, first it is increasing 1,280 Celsius, then it is 650 of magnesium, and then it's increasing 850. And once again, it is decreasing. So it means first it is decreasing, then increasing, and then decreasing. So that's why it is not clear trend of density and the melting point. What about in reactivity is increasing down the group. So we're going to see that which option is correct here. So reactivity is increase down the group. So that is correct. What about the density? It's not clear, and melting point is not clear. So D is our correct option here. So we're going to move to the next question. Question number 20. A new element, oxfordium, was discovered with the following property. So solubility, that's insoluble in the water. Electrical conductivity does not conduct electricity. And formula is OX2 mean it's staying in a form of diatomic state. And this kind of some valuable information we are getting. This is a diatomic the gas. So there's some type of element, sorry, that's an element. This is a diatomic element. Second, we have a bonding in a molecule that is OX. So that's a bonding structure is a given. It's making 3 covalent bond between that. So if it's sharing 3 electron and then there's no charge on that and getting stable state, so it means there were already existing 5 electron in outermost shell. So that's why it shared 3 electron and 5 plus 3 that become 8. So that's why it got stable electronic configuration as like nitrogen. So that's why it is present in the group 5 because it shared 3 electron to get stable electronic configuration. Second, it's present in the form of diatomic state as like nitrogen. So we can say it belongs to the group 5. So B is our correct option here. We're going to proceed to the question number 21. So which row describe the similarity and the differences between chlorine and bromine? So they both belongs to the same group, is a group 7 in the periodic table. And these are fluorine, chlorine, bromine, and iodine. So these are halogen and negatively charged elements. So we can see that the similarity, the both are gases at the room temperature and pressure. So you can see that the chlorine is the gas at the room temperature. What about the bromine is liquid at the room temperature? So that's why it is wrong option. So B, the both exist in a diatomic molecule. It is correct. And the chlorine is more dense than bromine. So we can see that at the room temperature, the bromine is in the liquid state. So that's why the bromine is more dense than chlorine. So that's why it is wrong option. So C, both have the atom with the 7 electron in the outermost shell. It is correct. What about only bromine will react with the aqueous sodium chloride? So we can see that if you're moving from up to down the group, the reactivity is decreasing down the group. So you can see that if there is a sodium chloride, so the chlorine is coming above the bromine. So chlorine is more reactive as compared to the bromine. So that's why the bromine cannot replace it from the sodium. So that's why it is wrong option. So both react with the aqueous potassium iodide. It is correct. So why? Because iodine is coming the down to the chlorine and bromine. So that's why it is less reactive. So both can react with the sodium in the presence of iodine. Now, chlorine is more reactive than bromine. So it's correct. Why? Because if you're moving down the group, the reactivity is decreasing. So that's why the chlorine is more reactive than to the bromine. So D is our correct option here. The question number 22. Which statement describes the transition element? So when we define about the transition element, so that's due to the presence of unpaired electron in the transition element. They have high unpaired electron between the atom, and they are making strong bonding. And due to this strong bonding, they have a high melting point and a high boiling point, and they have a high density, and they're changing their colors. They are colorful elements. So which option is correct according to the given information? They have the high densities and high melting point. It is correct option. A is our correct option. So B, they have high density and a low melting point. So low melting point is wrong. They have a high melting point due to strong burning. C, they have low density and a high melting point. So low density is wrong. They have a high density, and that's why the D is our wrong option. So A is our correct option. They have a high density and high melting point. They have a high boiling point, and they are colorful elements. So A is our correct option. The question number 23. Which gas is made when powdered zinc is added to the dilute hydrochloric acid? So there are some certain type of the metal which are reacting directly with the dilute hydrochloric acid. For example, aluminium, zinc, iron, and magnesium, they can react. What about other metal are not reacting? So we can see that the zinc is reacting in the form of powder form with the hydrochloric acid, that's a dilute hydrochloric acid, and that will produce the zinc chloride and hydrogen gas. So the C is our correct option here. The question number 24. The diagram represents the structure of solid. So here we can see the two different atoms are joined together, and they are not in regular compositions. There's not in a fixed ratio. It's not there. There's a regular, and there's irregular arrangement of atoms are there in that. So this is kind of mixture of two metallic atoms, and that's making alloy. For example, we can have a brass. There's a mixture of the zinc and copper that's mixed together, and that's producing an alloy. So which solid does the diagram represent? So brass, that is a mixture of two metals, and that is correct. Graphite, the graphite is making layered structure. That's organic molecule, and that's making a layered structure, but we can see there's no regular layered arrangement, so that's why it is wrong. Sodium chloride, it's making the regular arrangement of anion and cation linked together by an ionic bond, and that's making a regular lattice structure. But we can see that there is an irregular pattern, so that's why it's also wrong. So that's why it's also cross. So B is our correct option here. Question number 25. The steel is an alloy of iron. Which statement explains why the steel is stronger than iron? So we need to have a concept regarding that. So generally, the metallic atoms slide over when we apply the pressure on that. So if you're applying pressure on the metal, so these atoms slide off with respect to each other, and they convert into thin sheet. That is the malleability, or we can convert it into the wire. That's called ductility. So this also similar to the property of flexibility. You can also say. So what about the carbon atom? Between the metallic atom, they prevent the sliding of these metallic atom by applying pressure. So that's why it is giving extra strength by preventing sliding off of carbon atom under the pressure. So that's why this is the concept which is increasing the strength of metals. So we can see that in a option A, the steel contains carbon atom, carbon, which is very hard substance. So fine, the carbon can be hard in the form of the diamond or anything, but this is not a role of the carbon in alloy, so that's why it is wrong option. The carbon atom in a steel bond together very strongly. So this also not describing the actual role of the carbon, which is giving strength to the alloy of a steel. So the carbon atom in a steel make iron atom bond together very strongly. Now that's the strength of the bond. So it is also increasing, like this definition or this description is correct for the rubber, for example, for the strengthening of rubber, and we are aiding the carbon in that, and that's making a strong bond with the sulfur, and that's giving an extra strength. But here, that's not describing the actual role of the carbon. So actual role is what? The carbon atom prevent the layer of iron atom from sliding over each other under the pressure. So that's why it is giving the extra strength to the iron atom, and that convert into steel. So D is our correct option here. We're going to move to the question number 26. So 3 students, X, Y, Z, are told that the solid P react with dilute hydrochloric acid and also conduct electricity. So the table show the students suggested about the identity of this element, which is directly reacting, or this metal which is directly reacting with dilute hydrochloric acid. So in this way, we can see that there are particular metal which can directly react with a dilute hydrochloric acid. So what about other cannot react? For example, copper and graphite, they cannot react with a dilute hydrochloric acid. What about the Y can react? So that's why the C is our correct option. So the student Y suggested the iron. That is the correct option. The question number 27. Which statement explain why the aluminium appear to be unreactive? Here, more important thing is what? It is unreactive. So unreactive means it's completely not reacting. So the option number 1, it is coated in an oxide layer. So it's basically when sometime the outer surface of aluminium got tarnished by the aluminium oxide. So aluminium is reacting with the oxygen and they're producing aluminium oxide. So the outermost layer of this aluminium oxide cut off the direct connections of aluminium atom to the underneath to the reactant on the surface. So that's why the aluminium become completely unreactive. So according to this information here, we have it is coated with the oxide layer. That's why the A is our correct option. So B, it has a low density. So that's not relevant to, that's not describing. It is low in a reactivity series. So many metals are there which are low in the reactivity series, but you can say it should be a partially reactive. What about unreactive? Is not describing the low in reactivity series. It is solid at the room temperature. That's not describing this phenomena. Why? Because, for example, sodium metal or potassium metal, that is solid at the room temperature, but they are vigorously reactive. So that's why A is correct option here. So we have 28, the question number 28. During the electrolysis of aluminium oxide, the mass of the carbon anode changes. So which row describes the change and gives the reason for this change? So we can see if we are performing the electrolysis of aluminium oxide. So during this electrolysis, sometimes we are using cryolite, so it reduces the melting point of aluminium oxide and which is dissolving the aluminium oxide. So that's why sometimes we can say cryolite is used as a solvent for aluminium oxide. So here, in this reaction, what is happening? So at anode, so there is oxygen, and this will oxidize, and that will react with the carbon and produce carbon dioxide. What about at cathode? So aluminium, that will reduce at cathode and produce aluminium atom. So that's our overall reaction. We can see that in option A, that's decrease, mass change of the cathode anode is decreasing. So what's the reason why it's decreasing? Because carbon is reacting with oxygen. And when the carbon react with oxygen and that's producing carbon dioxide, so this carbon is coming from electrode. So that's why its mass is decreasing. So that's why it's describing correct reason for that. So A is our correct option. Second, B, decrease. Fine, it will decrease, but the carbon dissolve in molten cryolite. Carbon is not dissolving in molten cryolite. As I told you, molten cryolite is used to dissolve aluminium oxide. So that's why it is wrong option. C and D are a wrong option. Why? Because they're saying the mass will increase. It will not increase, it will decrease. Why? Because oxygen is reacting with a carbon in electrode and producing carbon dioxide. So A is our correct option here. We're going to proceed to the question number 29. The several processes are used to treat the domestic water. Which road identify the reason for the given process? So we can see that first we are performing chlorination. Chlorination is a process to remove impurities. So no, it is not used to remove impurity. Potassium chloride or chlorination is used to kill bacteria. So that's why the correct reason was used to kill bacteria. What about the filtration? Filtration remove insoluble particle. It is correct option because the main purpose of filtration is to remove insoluble particle. Sedimentation, we let the water to settle down the insoluble particle or to remove the insoluble salt. So what about here? He's saying that's a soluble salt. So that's why it is wrong option. So use of carbon, carbon in the form of the charcoal we are using to detoxify the water or not to kill bacteria. So that's why it is wrong option. So B is our correct option here. The question number 30. In a question number 30, what equation, what is the equation for photosynthesis? So what is happening in the photosynthesis? The carbon dioxide reacting with the water molecule in the presence of chlorophyll and sunlight, and it's producing glucose and oxygen. So we're going to check that. The first equation is the carbon dioxide is reacting with the hydrogen and producing alcohol and water molecule. So this is not photosynthesis. This is hydrogenation of a carbon dioxide. While the B, you can see the carbon dioxide is reacting with the water and that's producing glucose and oxygen. So that is our correct photosynthesis equation. Now the C, we have a glucose and this glucose will break down to produce the alcohol and carbon dioxide. So that is the anaerobic respirations. So we are breaking down the glucose without oxygen. So that's our anaerobic respiration in the yeast and in the plant. What about when the glucose will broken down in the presence of oxygen in the animal cell or plant cell and all living cell? So in the presence of oxygen, and that's producing carbon dioxide and water, that is aerobic respirations. So these A, C, and D are wrong options. So B is our correct option here. We're going to proceed to the question number 31. Which segment describe how the carbon and hydrogen in the methane gas in atmosphere contribute to the global warming? So in the global warming, we consider like methane and the carbon dioxide gas. These two gases are considered as the greenhouse gases. They're doing what? They're absorbing the heat, which the sun rays come and collide to the ground surface and they reflect back. And these gases absorb this heat from the land, which is reflecting from the land. And after absorbing this, some of this part, they reflect back once again to the earth. And in this way, what happened? Regional temperature increase. So that's a greenhouse effect. And this greenhouse effect caused the global warming across the world. And overall, the temperature of the world is increasing. That lead to perform a climate change. And these other activities are related with this phenomena. So we're going to see that which option is correct. So they absorb thermal energy from sun. So from sun is wrong here. In the B option, it's also wrong. In the C option, so they absorb thermal energy from Earth. It is correct. And emit all of this energy toward the Earth. That's wrong. All of this is not. And they absorb the thermal energy from the Earth and they emit some of this energy toward the Earth. So that's why the D is our correct option here. The question number 32. The structural formula of the two hydrocarbons are shown there. So we can see first is 4 carbon, that is, and they are single bondly connected with each other. You can see on the right side there is the structural formula, and in this structured formula there is a single bond. So this is what the butane, C4 at 10. In the same way, the second molecule is containing the same number of the hydrogen and same number of carbon, and this is isomer of the butane. This is isobutane. So these both have same molecular formula. but they have a different structural formula. So that's why these two are isomers of each other. So we're going to check that which statement is correct here. So they both are alkene. So that's not alkene, they are alkane. Why? Because they have saturated carbons. There's a single bond between carbon-carbon atoms. So they decolorize the aqueous bromine. So it's basically that's a function of alkene, and when it will reacting with the bromine and it decolorizes the bromine color. So that's the role of alkene, not alkane. What about here? They are structural isomers. So yeah, it's correct option. They are structural isomer. Why? Because they have a same molecular formula. But they have a different structure. For example, the carbon number 2, you can see the branch methyl group is present. So that's why they have a structural difference. So D, they undergo addition reaction. So it's not the addition reaction, so they undergo a substitution reactions. So that's why, because they are saturated carbons and every carbon have the valence shell are fulfilled with a single bond. So that's why they will not involve in an addition reaction. So they will go with the substitution reactions. So that's why it is correct. In an addition reaction, mostly if there's a double bond, so then they're involved in an addition polymerization reaction. So here, C is our correct option here. The question number 33. The structural formula of the compound Q is given there. So what is the compound Q? So you can see that in this compound Q, I drew a structural formula for this. So we have in the central carboxyl group, and with this carboxylic acid containing overall the 4 carbon here. So it means it belongs to the butanoic acid. So this butanoic acid reacted with propanol, and by the condensation reaction, removal of the water molecule, this produced ester bond. And that's where the oxygen came in between the carboxyl group and carbon. So that's one, we can give a name to this molecule. That is what, this is R, the propyl butanoate. Why propyl? Because this was propanol, it came from a propanol, and this is from a butanoic acid. So that's making an ester linkage, and this is producing propyl butanoate. So C is our correct option here. The question number 34. The fractional distillation of petroleum is shown there. So fractional distillation is what we are separating a different organic molecule on the basis of difference of their boiling point. So if the organic molecule which have low molecular mass or low hydrocarbon chain, and that has a low density and it has a low boiling point, and it will boil first. So it will get separate from others. So this type of separation is called fractional distillations. So here the question is, which fraction chain of hydrocarbon with the longest chain length? When we talk about the longest chain length, it means it has high density or high molecular mass. If there's a high molecular mass, it means it has a high density. So if it's a high density, so it has a high boiling point. So that's why it is our high melting point. So it will be present in the bottom of this fractional column. So the D is our correct option. This question might possible, which chain contain a shortest chain? So the shortest chain will be present at the top extreme. It will be with the shortest chain, for example, methane or ethane or propane. What about the D is our longest chain? So here, the D is our correct option. We're going to proceed to the question number 35. So which equation represent the cracking of the alkane? So cracking is what? The breaking down the larger hydrocarbon chain into smaller chain. So this process called cracking. So we're going to check that, for example, in option A. So we have the group that's ethene molecule. So we have 3 ethene molecule. So they are converting into a hexane. So mean alkene is converting into the alkane by addition polymerization reaction. It is not cracking. In the same way, we have a hexane. We have a hexene molecule. So this hexene molecule is adding hydrogen to convert into the hexane. How I identify this? For example, if you multiply 6 multiply 2, so if the answer is coming 12, so this is hexene, and 6 multiply 2 plus 2, so answer is 14. So that's a formula for hexane. So that's why with the reference of this formula, I can calculate easily. So here, by adding of hydrogen, it is converting of alkene to alkane. So that's why this is hydrogenation reaction, not cracking. In the same way, the C, we have a hexane. So this hexane is converting into the carbon and producing hydrogen. So that is dehydrogenation process. What about here in a hexane? And this hexane 6-carbon hydrocarbon chain is converting into ethene, and plus that's converting into butane. So that's why the long hydrocarbon chain is going to convert into the 2 short hydrocarbon chain. So that's why this process called cracking. So D is our correct option here. So question number 36, what is the structure of the product of a reaction of propane with bromine? So when the propene, so this is alkene, when the propene is reacting with the bromine, so what it will produce in the product? So you can see that here there's a structural formula for the propene. There is a 1 double bond present in the last 1 and 2nd carbon. What about it's reacting with the bromine, and 1 bromine will take on the carbon, and then this double bond will split into single bond, and the first carbon will get a radical, and in this way this will take on the remaining bromine, and that will bind with the 2nd carbon. So in this way, overall molecule will form, that is carbon number 1 and 2, both will aid the bromine. So that will form 1,2-dibromopropane. So that's why, according to this, we can see that the option C, we have a carbon number 1 and carbon number 2, both contain bromine. So that's why it is correct option. What about option A is wrong? Why? Because the carbon number 2, there is no bromine. Option B is wrong. Why? Because still there is a double bond. So that's why the double bond will break. That's why the bromine can aid in that. So option D is wrong. Why? Because the position of the bromine is wrong here. It's supposed to be carbon number 1 and 2, which contain double bond. So when the double bond will break, that's why that carbon, which have the deficiency of their valence shell bonding, so that will involve in the bonding. So that's why carbon number 1 and 2 should involve, not 1 and 3 should involve. So that's why the D is our wrong option. We're going to move to the question number 37. In a reaction R, the 2000 molecule of ethane react to form single molecule X. For example, we have a 2000 molecule of ethene, and they are producing a single X molecule. So which term describe this reaction? So we can see that, you can see on the right side, this reaction, for example, if there's a 2 ethene, they contain a double bond, and this double bond will split into a single bond. And in this way, they will make a bond with each other, this carbon, and this is called addition reaction. And in this addition reaction, a long polymer will produce. This is called addition polymerization reaction. So here we have a monomer, and this reaction is what? This is ethene, and this reaction is addition reaction. So on the basis of this information, we can see that the reaction type is what? Addition reaction. What about monomer? Mean the single unit is ethene. And the polymer, what is this producing? That's the polymerization process. So this is X's molecule that will be a polymer. So A is our correct option here. We're going to move to the question number 38. The part of the structure of the polymer is shown there. So here, this molecule also produce the result of polymerization reaction. So you can see that here we have a central, the atom and a central molecule, and it has a one side, the functional group carboxyl. Second side, the carboxyl functional group is amino acid. That's an amino group. So it's overall, this molecule is amino acid, and this amino acid is combining with another amino acid by a bond. One side, amino group, nitrogen, is directly combining with a carbon, that's carboxyl carbon. So it's making a amide bond, or it is called peptidic linkage. So it means so many amino acids, they are linking with each other by the condensation reaction, and it is producing polymer. So this polymer is called polypeptide, or it's called protein. So which statement about this polymer are correct? So we can see that option 1, the polymer is nylon. So it cannot be nylon. Why? Because it has same functional group at the both side of the monomer. What about, you can see in the nylon, there are same type of functional group. For example, if there is a hydroxyl, that's the same functional group are there at the both side of the molecule. What about here? The one side is carboxyl, other side is amino group. So that's why it cannot be nylon. So the number 2, the polymer is formed by the condensation reaction. So yes, it's right. Why? Because different amino acids, they are reacting. For example, amino group and carboxyl group, they react together and releasing water molecule and making this peptidic bond. So that's why this is correct option. This produced by condensation reaction. And the 3 option, they are ester linkage between a monomer. There's no ester linkage. Ester linkage is when the oxygen is coming between one side alkyl group, other side carboxyl. So that is an ester linkage, but this is amide linkage, or we can say this is peptide linkage. So that's why only 2 option is correct here. The C is our correct answer. We're going to proceed to the question number 39. The concentration of acid and alkalis can be determined by titration process. So which piece of equipment are needed to perform titration? So we are taking burette to measure the acid. So we put the acid in the burette, and we use the pipette to transfer base in the conical flask. So that's why these 2 operators are used, the 2 to transfer the base into the conical flask. What about 4 as a burette is used to measure the acid. So that's why these 2, the D is our correct option. What about the thermometer? And we need the syringe, graduated syringe is not used in titration. So D is our correct option here. The question number 40. Which chromatogram shows how the retention factor value of the substance is calculated? So we can calculate the retention factor by dividing the distance moved by the solute, dividing the distance moved by the solvent. So that's correct, the way to measure about the retention factor. So this way we can see that under option A. So in that option A, you can see X is a one solute and Y is another solute. So that's why it is wrong here. So Y over X, so solute divided by solute. So that's why it is wrong option. Here we can see that the B is an option. So X is representing a solvent, which is starting from baseline and end to the last point. This is move of solvent. So what about Y as a solute? So we can see the distance moved by Y divided by the distance moved by solvent. So that's why the B is our correct option here. What about here? See, the X is the solvent and Y is solute, but here is saying there is the X over Y, solvent by solute, so that's a wrong reference. So in the same way, the D is a correct measurement. For example, X and Y supposed to start from the baseline, but it's the starting from there and the above point. So this is logically incorrect. So the B is our correct option here. So we have completed this paper. Hopefully it will be helpful for you. If you don't understand any questions, so you can put your doubt in the form of question in the comment box. So I'll try to answer your questions, and hopefully it will be helpful for you. Thank you. Thank you very much.